I'm Gabor Lengyel. I'm at Central European University and I work with Joseph Fischer and Maite Lengyel. And today I will talk about my PhD, which is about object concept learning. So if we think about that, we see the world in a very unique way. So we don't see it as a continuous flow of different percepts, but we, and most especially our brain, does a very rigorous unitization. So we see objects around us, right? And all these, although it seems very natural, but it's not trivial why and how we see objects. So we could have perceived our environment in a less grouped and more continuous way. And the objects are actually the results of our brain processes and groups the information coming from our senses. And also we are not born with the capabilities of perceiving the environment how we do it as now as an adult. We probably learn it during infancy. So in my work, I work on how do we see objects around us and what computation our brain might do that leads us to perceive the world how we do it now. So what we think is that our brain tracks the number of co-occurrences of different parts in our visual environment, and it groups together those parts that co-occur very frequently as opposed to those parts that hardly appear together. And following this idea, in our experiment we teach people new objects based on the number of co-occurrences of abstract shapes throughout the experiment. For example, these shapes would always appear together during the experiment, forming an object, while these other shapes would hardly appear together. And this is somewhat similar to what we see in natural scenes. So after that, then we test whether our brain handles these new objects in a similar way how it handles real objects. And what we found out that if we learn new objects from these shapes, then we also, so only visually, we also immediately would predict that these the shapes within an object would stick together when we have a chance to grab and manipulate those objects. And what we also found out that if we highlight only one of the shapes, so if we draw actually the participants' attention to only one of the shapes in these newly formed objects, then their attention will automatically highlight all of the shapes within that object. And that is exactly what researchers found previously with real objects. So if we draw your attention to only one part of an object, your attention will highlight like the whole object, not just that one part. And based on these findings, we think that we learn to see objects based on the co-occurrences, or by learning the co-occurrences in our environment. And with this knowledge, we can build models showing the computations what our brain might do that leads us to see the world full with objects. Thank you.